Okay, so I'm going to be going over some of the double angle identity problems. These are like example problems and how to solve these specific types of questions. So first off, I'd like to mention that if you don't have your double angle identities either memorized or written down in a notebook or on like a cheat sheet, reference sheet type thing, definitely Google those and have those at your ready, because I'm going to be referencing them quite a bit. And I'll show you which one I'll be using, but it's easier for you to solve future problems if you have that as a reference sheet. Okay, so first off, let's say that you needed to find a specific value and find the exact value for it, but without solving for x. Now, in order to do that, you're first wanting to break apart the problem, and we're going to start kind of basic. I'm going to draw out my quadrants and a triangle that illustrates what this means. So looking at my example here, it's a little squished. I drew out my quadrants, so I have my quadrants 1, 2, 3, and 4, and then I also drew out my triangle. So given that sine x is equal to 1 over 4, using so out of SOHCAHTOA, and you know that that's sine opposite over hypotenuse. So your top answer is your 1 is going to be opposite, so that's opposite of your reference angle, so this would be theta. So this is always going to be your reference angle, no matter which quadrant this is. The one closest to the origin is your reference angle, so this is your theta. That angle, whatever side is opposite that angle, is going to be your opposite. And then, of course, the longest side is your hypotenuse. So we can label that as 1 and 4. And one thing I would like to note, and although it may sound very elementary, you want to remember to make butterflies, not spiders. So whenever you're drawing a triangle, make sure to come down onto your x-axis. You never want to start making out your angle and cross it over to the y-axis. You never want to do that, because then you'll make a spider, and we don't want spiders. Spiders aren't nice. Okay, so using my prior knowledge, I had my right triangle on my quadrant, and we knew that it was in quadrant 1. So then you do your Pythagorean theorem, c squared minus b squared, put it in the square root, and then you're going to result in a square root of 15. That can't be broken down anymore, so then you're going to go ahead and solve for cosine x, since you now have a hypotenuse and an adjacent. So for cosine x, that's going to be your square root of 15 over 4. Now, this is your opposite, that's your hypotenuse. Okay, so after that, now you're wanting to, this is where your double angle identities come in. So you're going to grab your little cheat sheet. I have my cheat sheet right here. So given that we have sine x is equal to 1/4, and let's just say we're trying to find a sine 2x. So in order to find sine 2x, you're going to head over to your double identities, and you're going to look at which one best fits. So of course ours is sine, and this one formula here is the only option for you. Cosine has multiple, tan has one. So anyway, we'll go over that later. So for our sine, you're just going to plug this in and replace your values. So I'm just going to explain what I did. So let's say we're trying to find sine 2x, and it's using our identity, our little reference, it was equal to 2 sine x cosine x. So you're basically rearranging the 2 in front of sine, and you're just plugging it in, and you're replacing what you've previously gotten with what you already had in order to not solve for x. Because if we had x, we could solve for the original problem, but because we don't, we're wanting to find the exact value without solving for x. So we previously found what our sine value was and what our cosine value was, because we were given our sine and we found our cosine by using our triangle, and then you just plugged in the values. So it would be 2 multiplied by 1 over 4 times the square root of 15 over 4, and that gives you a total sum of the square root of 15 over 8. Okay, so that is how you solve using your identities based on what you're given in a problem. If you were to use cosine, you would want to use whatever you have most of. That I'm trying not to confuse you. But like, let's say you're given cosine 2x. Well, because you were looking for cosine, you would probably use sine because we're given 1 over 4. So you would want to use your sine value that is alone. So it all depends on what you're given in a problem that is going to determine the easiest route for you to use. But if you're more comfortable with one or another, you can use that too. It provides less room for mistakes, rather. And it really doesn't matter which one you're using, because they're all going to end up giving you the same answer anyway. Just some are going to require more steps and more room for mistakes, and whatever way is most fitting for your problem is going to be the best route to take. But it's basically just plugging it in. You're replacing this value with one of these, completely replacing it, just like how we did over here. If you started with sine 2x, you're completely replacing with that identity, and you're plugging in the values that you need. Okay? So, moving on to simplifying expressions. Now, given that we have 4 sine 8x cosine 8x, now you're going to use one of your identities. So, in order to simplify this, it's most similar to our sine, and it starts with sine, so our only option is to use this one. So, now we're going to replace values, but notice that it's actually the exact same as our identity, except that it has a 4 in front of the sign. So because it has a 4 in front of the sign, we're going to actually need to factor this out. After looking at the problem and factoring out a little bit, you can confer that you'd get the same thing here if you multiplied this by 2. So let's just go ahead and do that to the other side. So then that would give you 2 sine 2 theta. Well, over here our theta is 8x, so then you would just plug in 8x for theta over on the other side, and then that gives you 2 sine 16x. So the entire reason behind that is you're just completely having to rely on those identities, and it might look a little bit scary sometimes and kind of like, hey, where am I even supposed to begin or start with this? You should kind of just start from an identity and just start plugging in things that you know are solid, and then you'll come out with an answer. I want to show you how to solve for solutions on the interval 0 to 2 pi. Sorry. Now remember that with a bracket, it means that it's touching, and with a parenthesis, it means that it's not touching. So that's kind of important, because if you have 0 and you're using a unit circle, hey, you're going to get the same value at 2 pi. But given our interval is bracket 0, 2 pi, and then a parenthesis, you're not going to use 2 pi in this case. So, yes, normally you would, but it doesn't because of the parentheses. So you have to make sure what your grouping signs are and be really careful about that. Now, the best way to approach this is actually look at what's common first and then pull it out. So first here we see that we have a 6 in front of sine. So I pulled out my 6. Now, we're also given the sine 2t. Now, this is actually an identity because this is our double angle. The angle has both a 2 and a t in there, and we're trying to separate that up. So let's look back at our double angle identities. And looking at that, well, given what we have, it looks like we can use our sine because we're given sine. So you can go ahead and replace the identity with what you have in your original problem. So I went ahead and replaced it with my identity. And one thing I did want to make note of is, my apologies if I confused you, but this 6 needs to stay the same because it's in a different term than the outside, because in the previous one, because this is all together. But it's separated by a plus sign, and if it's separated by a plus or minus sign, it's a completely different term. Think about it in algebra, where you have an x and a y term, and if it's put together and you have 2xy, x and y are multiplied. But then if you have 2x plus y, it's not added directly together because it's different terms. You can't combine terms that are unlike. You combine like terms. Anyway, so I just wanted to make clarification on that. So now, given that we have this, let's go ahead and completely pull things out of the problem. So now, altogether, we can pull a 6 sine t. Okay, now so I pulled out my 6 sine t, and looking at all of our problem, it's kind of like, what the heck? But if you were actually to multiply this back around and switch things around, you basically pulled out sine t, and it's kind of like pulling out an x. If you think about it, pretend that sine t is x and cosine t is y. So you have 2xy, and if you pull out an x, then you just are left with 2y. So then you bring down your 2 cosine t, and then plus 1 because you were able to fully bring out out of the whole problem. So like pretend this entire thing was in parentheses. Okay. Moving on. Okay. So now using zero product property, we can kind of split these up and equal them to 0. If you also remember from algebra that when you factor out something from like a quadratic equation where you have x squared plus x plus 1, you factor it out, then you have 2 groups of parentheses and you can equal it to 0 and you found your x and you found your solutions. So our entire goal here was to solve solutions but that were on the unit circle. So now you have your 2 solutions because these are basically in parenthesis and in parenthesis. So kind of like basic it down and try to bring up algebra if you need it. So now you have 6 sine t equal to 0, and that gives you sine t is equal to 0 because you divide the 6 on both sides, and 0 divided by 6 is still 0. So when your y value is 0, because sine is your y value, so when your y value is equal to 0, it's on the 0 or pi. Because remember, it normally would include 2 pi, but we're not including 2 pi because up here it says that it is not included, that 2 pi isn't included in that set. Okay, and then also including 2 cosine t plus 1 equal to 0, it gives you 2 cosine t after subtracting the 1 on both sides and then dividing by 2. So when your x value is equal to a negative 1/2, you find that on the radian 2 pi over 3 and 4 pi over 3. So you're going to need a unit circle for that, or if you haven't memorized, kudos for you, whatever works. One last thing I wanted to talk about was proving identities, and I'm not going to show you in the video because it's an extensive process. So looking at your double angle identities, you're really just wanting to plug things in. Whenever you have sine 2 theta, plug in this, and then whenever you have cosine 2 theta, whatever you're given in the problem and what most looks like it, plug this in replace of this value. So you're replacing this value completely. But if there's something else still in the problem, don't touch it. You're still gonna use that in trying to find it. You're just kind of replacing this with this. It's like saying, hey, this is x, and then hey, this is 1x. It's the same thing, but you're gonna insert a 1x into the problem instead of just x. Now, that's not the best example since it's a little bit different and a lot more numbers and things, but it's just, you have to kind of basic it down. Don't overthink it. Don't psych yourself out. Another thing I wanted to mention was your cofunction identities. Your cofunction identities, so sine theta is equal to cosine, and then theta minus pi over 2, and then negative cosine theta is equal to sine theta minus pi over 2. Those are also going to be used sometimes when trying to prove an identity. So just plug it in when possible and simplify when necessary. One little side note I wanted to include in here was whenever you're trying to use tan anytime, the actual identity for tan is not the easiest to follow, and it actually kind of makes more work sometimes. So thinking back to your prior knowledge that you've learned in pre-cal, sine over cosine is equal to tan. So if you have tan 2 theta, it's the same thing as sine 2 theta over cosine 2 theta. So just something to keep in mind when trying to solve for different things. Sometimes it's easier to plug in only 2 values instead of an entire identity where you're having to plug more in, do more work, and in turn it saves you a lot of time. So I just wanted to make that little note, and I hope all of that helped you and you have good luck on your work.